Welcome everyone to the fourth seminar today. Thank you for joining us. I'm Kara Brugman, a research scientist and outreach coordinator for FORCE.
And I'm Kyusei Tsuno, research scientist at FORCE.
Today we have Andrew Campbell speaking to us today about SEAs. But first, of course, I want to remind you that you can see a video of our previous seminars on YouTube. The video of this seminar will be posted next week. And you can sign up for our listserv on our website at force.asu.edu to be notified when that link goes live. We have one more seminar left this semester given by Ines and Izanwa from HBCAT. That will be next month on May 24th. All right, take it away, Kyusei.
Happy to invite Professor Andy Campbell in the University of Chicago as a speaker for seminar. Andy obtained a bachelor from Caltech and a PhD from the University of Chicago. And he experienced the postdoctoral research at Carnegie and then obtained an assistant professorship in University of Maryland, then moved to University of Chicago. He's a professor and the chair of the Department of the Geophysical Sciences. And he's also now a director of SEAS, Synchrotron, Earth and Environmental Sciences. So today he will be talking about the development and the progress of the SEAs. So Andy, you can start.
Okay, thanks very much for your introduction, and thanks also to the FORCE team for inviting me back. I attended a FORCE workshop in January and presented a brief introduction of the SEAs organization there, and benefited a lot from that. I had a great time learning about everything going on at FORCE, and I'm really grateful for the team for inviting me back to talk to the FORCE community more about SEAs. SEAs is Synchrotron Earth and Environmental Science. It's funded by the National Science Foundation, and it's relatively new. I'll continue to say new, less than 1 year old organization among whose purposes is to manage NSF support for Earth and Environmental Science focused synchrotron beamlines. SEAs is hosted at the University of Chicago, my institution, and we've got partnerships, sub-award partnerships with Stony Brook, University of Illinois Chicago, Stanford University, UC Santa Cruz, and the University of Minnesota, all of whom play a role in managing synchrotron beamline operations at each of the 4 synchrotron facilities shown here. That's the Advanced Light Source at Berkeley, the Advanced Photon Source at Argonne National Lab, NSLS-II at Brookhaven National Lab, and the Stanford Synchrotron Radiation Light Source at SLAC. Okay. Before the constitution of SEAs, most of the NSF support for beamline operations focused on the geosciences went through 2 preceding organizations, SECARS and COMPRES. The layout of SECARS is shown on the left. That's sector 13 at the Advanced Photon Source, and COMPRES was located at various beamlines spread across NSLS-II at Brookhaven, the Advanced Light Source at Lawrence Berkeley Labs, and APS at Argonne. COMPRES was the Consortium for Materials Properties Research in Earth Sciences, very much focused on materials property research in earth sciences. That's largely the mineral and rock physics communities. SECARS also enjoys a lot of activity from that field, but is a destination for a somewhat wider variety of earth sciences spanning high temperature and low temperature geochemistry, petrology, volcanology, meteoritics, environmental mineralogy, and a variety of other fields. SECARS and COMPRES, as I said, had operated for a long time, for more than 20 years each. SECARS, as I said in the previous slide, is focused at the Advanced Photon Source, sector 13, where there are 5 beamlines. COMPRES operated from 2002 to last year, 2023, and and had activity at ALS, beamline 1222, at APS, various beamlines, including 3ID, 6BM, 13 BMC, and a couple of stations at NSLS-II, namely the XPD multi-anvil press beamline and FIS, which is a high-pressure infrared facility. SEAS maintains these priority activities of COMPRES and GSE-CARS, merging their operations together while also expanding to serve growing needs of the broader Earth and environmental science community. We've got, in addition to maintaining, high performance in the operations that had been supported by GSE-CARS and COMPRES previously, we've got additional new investments in beamline support for various geochemistry, environmental science, and near-surface geophysics applications that I'll talk about more today. And this figure on the right, we'll call it a semi-quantitative, illustration of the growth of synchrotron productivity in the geosciences. Number of papers of year and some Google Scholar search. I should give a credit to Tom Duffy for this figure, by the way. Increased really rapidly following, starting around the year 2000, which is when GSE-CARS and COMPRES ramped up. And this productivity has increased continuously and continues to expand over, a broader and broader range of earth scientists and earth sciences. The goals of SEAS are to operate and continue to develop state-of-the-art synchrotron beamlines and associated capabilities to provide efficient and centralized management of the earth science support for these facilities, to generate a productive research environment, as well as train the user community. To enable new capabilities, taking advantage of technical advances, as well as the light source upgrades that I'll say a little bit about later on. To engage broadly with earth and environmental science researchers, identifying and supporting their needs. To develop robust education and outreach programs to not only assist users, but also to develop and to diversify the next generation of earth and environmental science synchrotron users. And finally, to represent the interest of this user base in our interactions with funding agencies, light source managements, and others in other contexts. A few quick facts about NSF's SEAS program are summarized here. It's a 5-year cooperative agreement that we have with the Earth Sciences Division of NSF. SEAS supports 36 staff in all. That's not 36 FTEs. There's some partial support, but 36 staff are supported by SEAS. This includes mainly beamline scientists as well as other staff. As I said in an earlier slide, or in the intro slide, SEAS is hosted at the University of Chicago, where I serve as the PI and director of SEAS. Our chief technology officer is Mark Rivers. Our outreach and inclusion officer is the newly hired Emily Padston. The director of GSE-CARS at the Advanced Photon Source is Joanne Stubbs. And I guess the three of them are shown in the upper row here to the right. The GSE-CARS staff are UChicago employees operating at mostly Sector 13 of the Advanced Photon Source. In addition, we've got partners at a variety of other institutions that help manage operations for synchrotron beamline activity at the various DOE facilities. These include Quentin Williams at the University of Santa Cruz. Quentin is the PI for the hard X-ray program at the Advanced Light Source. This includes beamline 1222, where there's diamond anvil cell applications, as well as new investment in beamline 832 for rock deformation experiments. I'll talk more about that today. Brandy Toner is kickstarting a new program of support for soft X-ray applications. There's Brandy here in the middle. Soft X-ray applications at the Advanced Light Source. This is a set of applications including it's called STIXM, scanning, transmission, X-ray microscopy, and also tychography imaging techniques that were previously unsupported by NSF for the Earth and Environmental Science community, and therefore that was an underserved community. And in developing the SEAS proposal, we recognize that as an opportunity for growth. So I'll talk more about the soft X-ray program later. Russ Hemley and Zhenshen Liu manage the high pressure infrared beamline FIS at NSLS-II at Brookhaven National Lab. They are based at the University of Illinois, Chicago. At Stony Brook, Don Widener and Matt Whitaker are, co-directing now the mineral and rock physics program that spans from the XPD beamline at NSLS-II, and I'll say a little bit about the HEX beamline at NSLS-II now, and also beamline 6BM at the Advanced Photon Source. And Sam Webb and Scott Fendorf are managing our support for Earth and Environmental Science applications at SSRL. And that is a variety of up to 10 beamlines with potential Earth and Environmental Science applications, or real Earth and Environmental Science applications. And we've got new beamline scientist support there. Shown here is the organizational chart for SEAS. It's managed by the National Science Foundation, or it's funded by the National Science Foundation through a cooperative agreement. The central office is located at the University of Chicago. I serve as the PI and director. Mark Rivers is our Chief Technology Officer, leading technological development across the SEAS network. Emily Padston is our Outreach and Inclusion Officer, responsible for leading our outreach, education, diversity, and inclusion activities. And we've also got, local support for administration, including accounting at the University of Chicago. The heart of the brain of the, decision-making process at SEAS takes place on the executive committee. I'll say more about them in, I think, the next slide. That's composed of myself as a director, our Chief Technology Officer and Outreach and Inclusion Officers, Mark Rivers and Emily Padston, as well as a number of facility representatives, including the subaward PIs and other senior beamline staff, as well as some at-large members, namely representatives from other SEAS structured committees, a representative from the Beamline Scientist Committee and a couple of representatives from the SEAS User Group Committee. More on that shown here. This is the current constitution of the SEAS Executive Committee. This is the group that discusses all of the major decisions to be made in SEAS. We've been meeting pretty regularly on a bi-weekly basis to discuss all things SEAS related. In addition to the team of subaward PIs and UChicago leadership that I showed here, we've got other members of the executive committee. All these are listed in no particular order at the bottom. Mary Jo Brounce from UC Riverside and Bin Chen from the University of Hawaii are newly elected. Thank you very much, Mary Jo and Bin. Newly elected members from the SEAS User Group Committee who have agreed to serve as representatives on the executive committee here. Also, Kat Armstrong, Beamline Scientist at ALS 1222, is our representative from the Beamline Scientist Committee. SEAS does more than manage support for experiments at synchrotrons. We've got the opportunity, with NSF having restructured support for Earth and environmental science oriented research at synchrotrons. We've got opportunity to optimize and integrate our activities across these sites. I've already mentioned the SEAS user group and how important it is for them to have representation on our executive committee, voicing the needs and interests of the user community. We have a beamline scientist committee that's been meeting regularly. This is already, in my mind, demonstrating an increased level of communication relative to the predecessor structure. Increased communication between the various beamline staff across the 4 DOE facilities. This gives them an opportunity to share best practices, share latest results, identifying technical issues, and opportunities to collaborate or to share best practice. And as I said in the previous slide, they do also have representation on the SEAS Executive Committee. Currently, that's Kat Armstrong from ALS 1222. And having combined all of the management for Earth and Environmental Science, beamline support under one roof, we're better able to optimize and share technical resources across the facilities. We can coordinate these between the SEAS sites to make sure that the user base is served as well as possible, optimizing capacity and, minimizing any unnecessary redundancies. We're able to share software and new developments in data management, as well as constantly developing software for data analysis and acquisition, and other, engineering needs, design and fabrication and so forth. So merging all these together allows more ready sharing of ideas and even, insight into, procurement opportunities across the different facilities. I've highlighted the user group committee. The newly elected co-chairs of that committee are Mary Jo Brounce from UC Riverside and Bin Chen from the University of Hawaii. Thanks again to the two of them for serving. Wenli B from UA Alabama, Martin Kuntz from Lawrence Berkeley Lab, Dan Shin from ASU, Jin Chang from UT El Paso, Wen Liu from the University of Maryland, and Claire Zerkowski, early career representative from Livermore, round out the rest of the user group committee. Thanks to all of them, and thanks also to the 140 of you members of the SEAS community who voted in this user group, and thanks also to the other 16 candidates who kindly stood for election. Summarized here are some of the other outreach, education, and other integrated activities that are either ongoing or that we anticipate under SEAS. We've got a number of new user programs proposed that are soon to be developed. We're building out a web portal for the user community that will, over time, gradually have, better and more exhaustive information for new users. How do you identify what is the best beamline for your experiment? That kind of question. COMPRES and SECARS had a history of running workshops to improve the education of the community for new as well as established techniques. That will continue under SEAS. That's especially important now that we're introducing a variety of new capabilities or new beamlines. So these workshops are under development. I'll say a little bit more about some opportunities as we go through, but we've got, for example, the Soft X-ray program is co-hosting a workshop at the NSLS-II user meeting that in just, I think it's 2 weeks. Collaborating with other programs, right? SEAS doesn't have to always take the lead on, outreach and diversity programs. We also are well positioned to collaborate with programs that are run by, you in the FORCE community or others in our SEAS community. And of course, incorporating Be a Jedi principles into all activities, as we all expect for all of our NSF funded or any other activities. Emily Padston is our new outreach and inclusion officer, having joined the team just recently. Emily's shown in the lower right there. She is a member now of the SEAS Executive Committee, paying attention to all of the major decisions that go on at SEAS and making sure that we're incorporating Be a Jedi principles into these activities and looking for opportunities and providing feedback on developing education and outreach programs across the SEAS sites. She is our primary contact for those of you who would like to reach out to develop a partnership with us for education outreach activities at the SEAS facilities. Many of you are longtime users, perhaps, and sort of have an understanding of how SEAS works, but some of you may not be. So I've got I'll briefly describe it here. The SEAS organization leverages for beam time access for the Earth and environmental community. We provide beamline staff and in some cases equipment, and in exchange for this, we negotiate agreements with the DOE Synchrotron facilities to provide dedicated, preferred access of beam time for our user community. There are various types of agreements with different, sort of complexities that I don't have to get into, partner user agreements or other, approved programs or other agreements, depending on the facility. But an important aspect of all of these facilities is that the SEAS team doesn't keep this dedicated beam time to itself. In most of the partner user agreements or other agreements at the various DOE facilities, the normal operation is that the partnering team is maybe a small group of PIs who are representing, themselves or interest of a small group or an industry. SEAS operates on a different model where our team is doing that work to provide preferred access for all of you in the Earth and environmental science community to help you take advantage of new opportunities in synchrotron research. The general user system is the basis for most of the beam time assignment. A beam time user or potential beam time user would submit a general user proposal that goes through the normal general user process. And then our partner user time, it works differently at different beam lines, but in an ideal sort of description, our partner user time is then available to those users who didn't manage to be awarded general user time in a given cycle, and we can assign this dedicated time according to the ranking in the GU system or through other criteria. For example, preferred access for new users or in support of an outreach and inclusion program, some sort of educational process. The overall picture of the beam lines and their capabilities and the user access agreements that we have at the 4 different synchrotron facilities are tabulated here. I'm not going to go through the table, in detail, but I wanted to give you this sort of visual sense of the fact that our beam lines are distributed across 4 different synchrotrons. They're color coded here. That's the advanced light source, advanced photon source, NSLS-II, and SSRL at SLAC. We've got a variety of beam lines at each one of these facilities where SEAS support is active. Those beam lines that are and their descriptions that are colored here in black text indicate what existed prior to the establishment of the SEAS program. So this was SECARS and COMPRES. Those are in black. And then the SEAS program is continuing to support all of those at a high level of performance, as well as expanding opportunities as indicated in the red text here. So I'll sort of work through each of the synchrotron facilities and highlight what's going on one by one. But you get a sense of the degree of sort of new activities or new capabilities that have been introduced by SEAS since our start date that I neglected to mention of September 1 in 2023. So we're only about 7 months into it. Some of those enhancements are read or summarized in this figure. I don't have, images for all of them, but I'll briefly describe beamline upgrades that are ongoing at APS, especially in support of the, currently happening APS-U upgrade. We anticipate some expanded access at 6 p.m., and I'll talk a little bit about that. I've got highlighted in bold here because it corresponds to the image on the right. New, C's support for applications in rock deformation, near surface geophysics applications, and we anticipate support for applications like this at several beamlines at APS 6 p.m, at ALS, the hard X-ray beamline 832, as well as some opportunities that aren't directly I'll discuss the agreement there at the emerging hex beamline at NSLS-II. We've got new support for X-ray microprobe or X-ray spectroscopy beamlines. This covers quite a few, up to 10 beamlines at SSRL, and a new beamline scientist also at the XFM station at NSLS-II for X-ray microprobe and X-ray imaging and spectroscopy applications. And I already highlighted a little bit the new developments in soft X-ray applications of the Advanced Light Source. This is the sister program that I'll say a little bit more about later on, providing access to STXM applications as well as soft X-ray tachography applications. Shown over here on the right is the triaxial deformation cell. This one, there's a variety of these, designs out there. This one's called the Mjolnir cell, and I'll show some briefly some sort of new results illustrating the potential of using triaxial deformation cells like these for rock deformation studies at some of these beamlines. At the Advanced Photon Source, SEAS, GSECARS, like GSECARS and COMPRES before it, operates across mostly at Sector 13, but also activity at Sector 6 and Sectors 3 and 30. Many of you are already users, I'm sure. And we span a wide variety of X-ray applications. The diamond anvil cell high pressure applications are important contributors at sectors 3 and 13 especially. There is a number of tomography applications, and I'll say a little bit more about that in terms of the rock deformation applications. X-ray absorption spectroscopy, inelastic X-ray scattering at sectors 3 and 30, large volume press applications at sector 13 as well as 6 p.m. There's general diffraction, including surface and interface scattering at sector 13, and X-ray microprobe capability also at sector 13. In addition, GSECARS beamlines offer very helpful offline user laboratory capabilities, including Raman spectroscopy, micromanipulator, an FCM and other applications. So this is a full service station for earth environmental science applications at sectors 13, 6, and 3 at the Advanced Photon Source. However, currently, the Advanced Photon Source is in the middle of, well, actually nearing the end of an upgrade. And I'm realizing now this slide is a year old. What it says here is APS today really means a year ago. The profile of the electron beam in the ring prior to the APS-U upgrade, had dimensions illustrated by the red distribution here. And the upgrade, which is happening now, and in fact they currently have stored beams, I think up to 0.5 milliamp right now. So that's up and not ready for user operations yet, but in the early stages of commissioning. And the profile of the beam now looks like this, and you can see that's a huge increase in the resolution or brightness of the beam, and that's going to greatly enhance applications in many of the needs for Earth and Environmental Science users at the APS. The next few slides, I'm going to briefly introduce the nature of the upgrades that are ongoing at Sector 13 in anticipation of APS-U. Shown here is a sketch of a diagram of the layout of GSECARS Sector 13 at the Advanced Photon Source. The red ovals here indicate places where the X-ray optics or other enhancements are being upgraded. In addition, listed here are some other upgrades that are being implemented now in anticipation of the rise of APS-U. Some of these are directly supported by SEAS, including improved X-ray optics in the 13 BMD hutch, a variety of improvements to the laser heated diamond anvil cell system in 13 IDD. This includes a granite table and other components that will greatly improve the stability of that system, which is necessary to take advantage of the dramatically improved spatial resolution for that beamline. There's also a new X-ray detector coming on at 13 IDD, and that's available to the community through instrumentation and facilities grant with the Carnegie Institution. That was led by Alex Goncharov at Carnegie. A new diffractometer in 13 IDC, and upgrades to the optics and stage in the microprobe station at 13 IDE, also to improve the stability and the resolution to take advantage of the improved spatial resolution and greater focusability following APS-U. This dark period at the Advanced Photon Source began 1 year ago. 1 year and maybe a year and a week ago, I think it was, in April 2023. As of a couple of days ago, they had stored beam current up to 0.5 milliamp. When they're at full operation, they will be up to 200 milliamps. So they've got a ways to go, but they're improving on a nearly daily basis. Commissioning continues while the ring current ramps up. And what we anticipate currently is that many user operations at the C-supported beamlines will be available at some point in the 2024-3, meaning the fall 2024 cycle. So let me just, yes, that's to the forest community, among the most compelling techniques at the C-supported beamlines at the APS might be the large volume press techniques. And I've got a slide here just illustrating the array of applications that are available at the APS alone. At 13 BMD, there's a D-dia press for mono X-ray diffraction and imaging. Also high pressure, high temperature tomography using pink beam imaging or white X-ray diffraction. In 13 IDD, there's a 1,000-ton multi-anvil press for X-ray diffraction and imaging, or D-dia for deformation studies using X-ray diffraction and imaging. There's also a press at 13 IDC, a Paris-Edinburgh press for the study of liquids. And at 6 BMB, there's the D-dia press for white beam X-ray diffraction for rheological studies and ultrasonic studies of materials at high pressures, as well as the RDA module for imaging during high pressure, high temperature shear deformation to high pressures. So these are currently available large volume presses at the APS, but that's not all that SEAS has to offer the forest community. In addition, we've got high pressure, high temperature mineral physics applications, including multi-anvil press applications at the XPD beamline at NSLS-II. Matt Whitaker, shown here, is the beamline scientist principally responsible for operations of the XPD, the press at the XPD beamline, the MaxPD program. And that is the sort of a continuation from the COMPRES-supported program which previously had operated at NSLS-I and has got a long history of success in rheological and deformation studies, as well as ultrasonic experiments at high pressure and high temperatures, and a number of other applications, equation of state and phase diagram studies at NSLS and its predecessor beamline for more than 20 years. A new development at NSLS-II is the opening of the hex beamline, which is nearby XPD. This is at beamline 27 ID. This is a unique beamline in the US, offering very high energy and high flux and a very large beam. The SEAS partner user agreement that's being developed at NSLS-II does provide some dedicated beam time at XPD, sort of continuing on the sort of management plan that we had in place for COMPRES. At the hex beamline, we don't have dedicated time, but there is access to the general user program, and SEAS can offer some beamline support through staffing there at NSLS-II. There were, big news there is some commissioning experiments that were done. These are, I think they were among the first experiments to be done at the HEX facility following a workshop in October 2023. A team listed here, including Mark Rivers and others from SEAS, as well as Wemley Drew from Maryland, and you can see the team there perform some early experiments, and were able to get what they describe as excellent tomography results in a Mueller type rock deformation experiment within 1 day of their first beam. They could observe crack formation and sample failure on a variety of rock samples in this deformation cell. An image of that, this is just one slice of the three-dimensional, tomographic image that was obtained, in this case on granite after failure in the triaxial cell. Apologies, I don't have a scale bar there. I believe this sample was maybe 6 millimeters in diameter. And that facility is capable of obtaining not only tomography data, but also diffraction data. The instrument is shown here. This is the deformation cell that's capable of achieving sort of crustal deformation conditions. This is the pumping stand for it, and this was brought to the beamline by the SEAS team. And this is the portable imaging or temporary imaging system that was used for this experiment. So that was a success illustrating the potential for rock deformation and near-surface geophysics applications at the HEX beamline, as well as others in the SEAS network. Before I leave SEAS activity at NSLS-II, let me point out, say a few more words again about our high-pressure infrared spectroscopy program. Here on the left, Zhenshen Liu is the beamline scientist that you know well if you're a user at that beamline. They've got some new continuing developments in place, including applications for in-situ high pressure and high temperature applications. They've got a membrane control, externally heated diamond anvil cell developed, and they're working on coupling CO2 laser heating with high pressure infrared microspectroscopy. The main focus of this beamline has always been high pressure applications, but I'd like to point out that there are other potential applications for infrared spectroscopy, synchrotron based and infrared spectroscopy to earth and environmental science users at FIS beamline. For example, they had an outreach program there, I think it was last summer or fall, where they used the FIS infrared spectroscopy system to identify microplastics that were collected in the environment around Brookhaven National Lab, or there on Long Island. So there's a wide variety of applications that are probably, I guess, underexplored for high resolution infrared spectroscopy at the FIS facility. As I mentioned earlier, I think there's also new support for X-ray fluorescence microscopy at the XFM beamline at NSLS. Beamline scientist hiring is underway. We expect beamline scientists there in the not too distant future to further support Earth and environmental science activity at that beamline, and the partner user agreement for that beamline is under development. At the advanced light source, we have both hard X-ray and soft X-ray applications. The hard X-ray applications are illustrated here. Beamline 1222 is a long successful program that had been supported by COMPRES and continuing on under SEAS. Beamline scientists Bora Kalkin and Kat Armstrong are shown here, not to scale. And new investment in the hard X-ray program at the advanced light source is in the form of, again, in situ rock deformation studies. And this is another one of these cells for sort of crustal conditions and maybe hydrothermal applications where you can have, where you can monitor, crack formation and evolution, as well as, track mineralogical changes associated with the deformation. And once again, beamline specialist hiring is currently underway at that facility. Also, at the advanced light source is the soft X-ray program. This is synergy of soft and tender X-rays for Earth research. That's led by Brandy Toner at the University of Minnesota. The acronym we use there is the SISTER program, and that's spread out across multiple beamlines, 5321, 5322, 7012, and 11022, all at the advanced light source. Previously, there were general user programs, but they've been heavily oversubscribed, and their capacity for and access for Earth and environmental science users have been limited. Developing through SEAS and SISTER, we've now got expanded access and improved capabilities being developed at these and other and nearby beamlines. This program is up and running. You can now apply for beam time at the advanced light source, and through the drop-down menu, select that you are that you intend to be a SISTER user to do soft and tender X-ray applications at the advanced light source. Postdoc Sarek Matson is already hired by the SISTER program, and he will be on for much of 2024. A lot of his work has been developing outreach programs, including workshops that are being developed to sort of better introduce these applications to the environmental science community. Recently, the SISTER program has also hired beamline scientist Lim Kang, who will be arriving in August 2024 to be more permanently stationed at these beamlines. An exciting thing about these beamlines is the emphasis that the advanced light source is intending on soft and tender X-rays in their upcoming upgrade. The advanced light source is going to be undergoing an upgrade a year and a half or so after the APS-U upgrade is complete. And when they restore to operations, they'll have enhanced coherence and enhanced flux in the soft and tender X-ray region of the spectrum. So there's going to be a bright future, so to speak, for these applications. Yeah, I'm running a little short on time, but very briefly, here's an example of the type of SISTER science. I know this may not be what you came for if you're in the force high pressure community, but it's important to recognize, these other new developments, because you never know what interesting application you'll realize by hearing about what other people are doing. This is an example where they're analyzing colloidal material from hydrothermal plume particles that are expected to be a source of iron for the phytoplankton uptake in the oceans. They've got stereo microscopy. Oh, this came from Brandy Toner 2023 and Sarek Matson unpublished work. Thank you both. Shown here is an indication of the type of spectromicroscopy you can do in the soft energy range. And this figure in the lower right is an image of the iron 3+ distribution using ptychography of these colloidal particles. So this is a 100 nanometer scale bar here. So you can see that the spatial resolution they've achieved in this imaging of iron 3 is, 10 nanometers or better. And wrapping up our tour of the synchrotron facilities, once again, SEAS has operations at the Stanford Synchrotron Radiation Light Source, SSRL. Beamline scientist Eleanor Spielman's son has been there since November, I think it was, to support Earth and environmental science users all around the ring. The beamlines that are most popular for environmental science and low temperature geochemistry users of this beamline are imaging beamlines, 2.3, 6.2b, 7.2, 14.3b, and X-ray spectroscopy beamlines, the ones listed here. So, yeah, so the Eleanor is there to provide enhanced support for Earth environmental science applications of all kinds around the ring at SSRL. I'd like to wrap up by emphasizing some of the synergies that are obvious or maybe less obvious between the FORCE program and the newly running SEAS program. There are a variety of ways that our very much overlapping user communities can benefit from the coexistence of FORCE and SEAS. To highlight a few sort of simple examples, sample preparation can take place at the various FORCE facilities that will improve the quality of some experiment that is imagined to be executed at SEAS or some other synchrotron station. For example, high quality synthesis of high pressure, high temperature phases are really important for improving, the performance of our in situ large volume press or in situ diamond anvil cell experiments. This can go in the other direction as well. The FORCE experiment might be, the primary experiment, and then SEAS can contribute, or other synchrotron, X-ray or other synchrotron applications can contribute towards post-recovery analyses of those experiments. X-ray spectroscopies, inelastic X-ray spectroscopies and tomography are some, obvious applications that come to mind. Yeah, in addition, I'll just point out that the SEAS staff at these synchrotrons are knowledgeable about a wide range of applications. And even if, the application that the FORCE user really needs to analyze their sample is, even if it's not offered by a SEAS facility, the likelihood is good that talking to our staff can help direct you FORCE users to some other beamline that, where you can gain what you need. The FORCE, one of the exciting applications intended by the FORCE facility is to pursue, large volume and increasingly high pressure, large volume applications using, for example, sintered diamond anvils. Sintered diamond, anvils. This will require some development in pressure calibration, and I think in situ studies, at SEAS facilities can contribute to that. As was certainly done in the days of COMPRES, calibrating load versus pressure for particular designs of the anvil design or gasketing design for these experiments. And perhaps most important is the opportunity for community cooperation of various kinds. Even when I was at the FORCE workshop in January, I had a really beneficial conversations with leadership of the FORCE team, as well as other members of the FORCE community, about how we can coordinate on future workshops and meetings and other events that will appeal to our overlapping, user base. And likewise, it's easy to imagine all kinds of outreach and education opportunities that would link the facilities together. Just as an example, I can imagine, a summer internship project where a student might, perform syntheses at a FORCE facility and then carry their, sample for some analysis at a SEAS site all within a summer, if well scheduled. A number of opportunities are possible, and they don't have to be led by FORCE and SEAS leadership. These are opportunities for partnership with you and the user community. And finally, I'd like to give a big shout out to the ISRD RCN. That's the In-Situ Studies of Rock Deformation Research Coordination Network funded by NSF. This group of scientists have been working for several years now at a series of workshops on identifying ways to integrate synchrotron and other types of beamline technologies to improve rock deformation experiments, or to improve the interpretation and the analysis of rock deformation experiments. The steering committee and the advisory committee are listed here. As you can see, it's a broad national, and I'm aware even international effort. And you know, the work from this community was really influential in visualizing, you know, aspects of the SEA's proposal, and led to the sort of support for rock deformation applications that I briefly highlighted today. And finally, almost finally, I need to acknowledge the Synchrotron Geoscience Steering Committee, which, you know, years ago now, in 2021 and 2022, developed what became the SEA's proposal. So this was a broad-based community effort that got behind, like I say, what became the now SEA's organization. It was chaired by Tom Duffy, and there were 17 others involved in that effort sitting on the committee, as well as many other contributors to the SEA's proposal, and hundreds more Synchrotron Geoscience community members who participated in all the town halls and workshops and the public PI interviews and other feedback that was provided to this steering committee. So thanks to all of them once again. And finally, really finally, there is more SEAs to come. As I described today, there's beamline access that is still on the horizon that SEAS is going to be supporting. We've been staffing up substantially, but there's still a few more staff to be hired. There's more community program in the form of workshops and you know, other opportunities for learning about synchrotron earth and environmental science applications. I highlighted APS-U, which will come online towards the end of this year, which is going to have tremendously improved capabilities in spatial resolution and brightness, as well as also improved coherence. And then a few years from now, as I briefly mentioned, we'll also look forward to the upgrade of the advanced light source that will provide enhanced intensity and coherence, especially in the soft X-ray part of the region. You can hear more about this by joining the SEA's users email list. Reach out to me if you are not already on it and would like to be added. Thanks very much. I'm happy to entertain any questions you have.
Thanks, Andy. If anyone has any questions, you can raise your hand and we'll call on you. You can unmute yourself. If you'd like to, you can also type your question in the chat and I will read it out. I see some applause.
Thanks.
Dan, go ahead.
Hi, Andy. Thank you so much for the talk. It's exciting. There are some facilities where people like me who bring diamond cell, for example, can take advantage of one-stop shopping, for example. So when we go to Synchrotron, for example, NSLS-II has beautiful infrared beamline. And when I bring diamond cell there, I like to also conduct X-ray diffraction experiment just to make sure that I have a right sample to do IR, for example. If I would have to do that at APS, that is going to be 2 trips, much less desirable. And now with SEAS, I think you guys have a capability of coordinating this type of measurements that would enhance users' productivity and quality of experiments. So do you have any plan for such activity coordination?
So yeah, we do have actually a plan for coordination, maybe not the type of coordination that you were specifically asking for, but let me use this opportunity to highlight the fact that the beamline scientists that we are about to station at the XFM beamline is stationed principally at the XFM beamline, providing support for the X-ray microprobe capabilities there, but also will have the capacity to help we envision it as mostly, users in geochemistry and petrology and environmental science, but to help users around the ring to get in their efforts on, in most cases, general user time at other beamlines. So we do envision that XFM station beamline scientists will be able to support Earth environmental science users at sort of parallel beamlines. The TES beamline comes to mind immediately as something that class of users might be especially interested in. And I already indicated how Matt Whitaker was part of the team that performed those commissioning experiments at HEX, and can assist with general users who from our community who also get time at HEX. If there is there's probably an X-ray diffraction beamline that's suitable for, that can be made suitable for diamond anvil cell experiments at NSLS-II. But I don't know which one it is. Yeah.
Thank you.
Yep.
All right, do you have any other questions?
Somebody's in the chat.
Matt says, we've done preliminary experiments at XPD.
Oh, okay. I'm assuming that means preliminary experiments with the diamond anvil cell at XPD. Yeah.
He says, very preliminary with very in all caps. Yes.
Thanks, Matt. Very helpful.
Okay, if there are no other questions, Andy, thank you so much. I'm looking
Been a
forward to
pleasure.
see what comes out of C's in the future. I did not intend that to be a pun, but
I did.
all right, thank you, everybody. See you
Okay,
next
thanks,
time.
everyone.